Lesson 19. Our topic for this lesson is going to be electricity, but specifically we're going to be talking about direct current, voltage, and resistance, as well as how they come together to give us Ohm's law. Now, electricity is going to be a very different part of physics rather than what you have been taking a look at so far, which has been mechanics. Let's take a look at our objectives. The first is to be able to define these things that we're going to be talking about: current, voltage, and resistance, as well as to be able to explain the relationship between the three of them. You will also want to be able to use Ohm's law, which is what brings these three things together in order to solve equations. Now, one of the things that you will have noticed when you watched the video before this lesson is that when Bill Nye explained electricity, he always used an analogy. He always said something is like something. And that's because when we talk about electricity, what we're really talking about are subatomic particles. We can't see them, so we always have to explain them by saying they're like things that we could actually see. Let's start by taking a look at current. So Bill Nye, when he was talking about current, said that current is the flow of electrons. That's our definition, the flow of electrons. But the way that he explained it was by saying that the flow of electrons is like bees as they buzz from hive to hive. The hive itself doesn't move. The hive is like the nucleus of the atom. The bees are like the electrons and can move from atom to atom. He also said that the flow of current through a wire is like water flowing through a hose. So we have a flow. And once we have that flow going, we can do work. So note that when we have current, it's the flow of electrons, not protons. Protons don't move around. Our unit for current is called the ampere, sometimes just shortened to amps. An ampere is actually our fundamental or basic unit in electricity. We abbreviate it as a capital letter A. Now, 1 amp is actually kind of big, so a lot of times you will see milliamps or MA. So take note that when you see MA, that it's actually milliamps, and will probably have to be converted to amperes just by doing a metric to metric conversion. The symbol that we're going to use to represent current in our equation isn't quite so nice. They use a symbol of an I. I can tell you that a C is already used for something else in electricity, so you don't want to use a C. Now, we have two types of current that we encounter in everyday life. The first is called direct current, which is the flow of electrons in only one direction. It's direct. We get this type of current from batteries. We also have what we call alternating current, which is the flow of electrons back and forth. This is caused by magnets, and this is the way that power plants produce electricity. Since we get our electricity for our houses and buildings from power plants, this is the kind of electricity that we get from electrical outlets. For simplicity's sake, we are only going to be concentrating on direct current. Okay, next we have voltage. And Bill Nye explained voltage by saying that voltage is like the pressure pushing the water through a hose. Let's start with an explanation into the subatomic way of explaining it. A battery has what we call stored or potential energy. There's energy just sitting there waiting to be used. So it has potential energy because it has the potential to do work. So this electric potential energy has the potential to do work when the electrons move. In a battery, the two sides are very different. One side is positive and the other side is negative. So there's a difference between the two. So we say that this electric potential energy is a potential difference because when we connect the positive and negative sides of the battery, we have the potential for work to occur because of this difference. Potential difference is actually the correct name for voltage. This push of electrons caused by the potential difference is sometimes referred to as the electromotive force. So this is like the way Bill Nye was explaining it. the pressure pushing the water through the hose is the electromotive force pushing the electrons through the wire. Both the potential difference and the electromotive force are usually just called voltage. And they're called voltage because of the unit. The unit is volts, abbreviated as V. But we just say that volts is a measure of the voltage. Something that you may have noticed in the video also is that when Bill Nye talked about current, which is measured in amperes, he called it amperage. So current is sometimes referred to as amperage through its unit, and potential difference and electromotive force are referred to as voltage because of their unit. The symbol that we're going to use to represent voltage in our formula is a capital letter V. Now I know that we've used V for volume, but you won't get it confused because voltage and volume are not going to appear in any formulas that look anything alike. Let's move on to resistance. Before we can actually define resistance, we need to talk about some properties of substances. And that is that they can either be what's called a conductor, which is a substance that allows electrical current to pass through it. Metals make really good conductors. Or they can be insulators, a substance that does not allow electrical current to pass through it. Nonmetals make really good insulators. You'll note in any kind of electrical cord that the wire inside is made out of a metal. That's the part that conducts the electricity. The outside part of the wire is going to be either plastic or rubber. Because plastic and rubber are nonmetals, they don't allow the electricity to conduct outside of the wire. So things have their purposes whether they're conductors or insulators. So then, what's resistance? Resistance is a measure of how difficult it is for electricity to pass through a conductor, or how much a conductor resists the flow of electricity. To go back to the analogy that Bill Nye was using, he didn't really talk about resistance, but we can extend his analogy. If we have a hose and it's a short hose, then the water is going to be able to flow through it a lot easier than if it's a longer hose. The length of a wire can affect the resistance, how much the wire is resisting the flow of electricity through it. The same thing can happen with the thickness of a hose. If you have a fire hose as opposed to a garden hose, the fire hose will allow the water to flow through it much easier than a garden hose because it's so much thicker. The same thing for a wire. The fatter the wire, the easier it is for electricity to flow through it. The narrower the wire, the harder. So a narrow wire has more resistance. It resists the flow of electricity more. Now, onto our unit. When we talked about current, current is measured in amps, which is abbreviated as A. Voltage is measured in volts, which is abbreviated as a V. The unit for resistance is called the ohm, named after the scientist Georg Ohm. But we can't really use an O to abbreviate an ohm because an O looks like a zero. So what scientists did instead was they used a Greek letter O, called omega. It kind of looks like a horseshoe. Although, when we use the symbol's a lot nicer. The symbol in our equation for resistance is a capital letter R. Now, it may seem like resistance is a bad thing in a circuit, and sometimes it can be, but other times it can be a good thing. If we have a circuit that doesn't need a whole lot of electricity, we need to be able to slow down the flow of the electrons. So scientists have developed things called resistors, which are devices that are used in circuits to control the voltage and the current. If you've ever taken anything electrical apart, you may have noticed a resistor inside. It looks like a cylinder, and it has colored stripes on it. The colored stripes are a code to tell you how much resistance it has. Now, the scientist Georg Ohm was able to figure out some relationships between current, voltage, and resistance. And what he noted was that voltage and current are related to each other directly. The higher the voltage, the higher the current that can flow. So we say that they are directly related to each other. If we use the analogy, the higher the pressure in a hose, the more water that can flow. He also noticed that resistance and current are related to each other. In this case, it's what we call an indirect or an inverse relationship. The higher the resistance, the lower the current that can flow. As one goes up, the other goes down. He was able to put these into an equation. It's a very basic equation which says that the voltage equals the current times the resistance. This formula is a very basic formula and forms the basis for any electrical type of equation that you will ever come across. Since there are three things in the formula, you will be able to use a triangle. When you put this formula on your formula card, you will want to put it on the back next to the column that says basics. At the top of the column, you can entitle it electricity and put down Ohm's law. Let's take a look at an example. A person connects the positive and negative ends of a 9-volt battery with a piece of copper wire. Copper wire has a resistance of 20.9 ohms. What is the current flowing through the wire? So we start by identifying what we're looking for, which in this case is the current, which is symbolized as the letter I, remember. Whenever you see that you have an electricity problem, you can put down Ohm's law, because that's what you're going to be using to solve it. Now notice that we need a voltage and a resistance. So it tells us that we have a 9-volt battery, and that we have a resistance of 20.9 ohms. So now we can substitute these values in. If you use the regular equation, notice that you'll have to do some algebra. If you use the triangle, you'll notice that immediately you can divide 9 divided by 20.9. When we divide, we get 0.43 amps. Amps for current. Now notice that I didn't put the units in this equation when I solved, and that's because if you try to put the units in, it'll be far too confusing. It's much easier for you to memorize that current is measured in amperes, voltage is in volts, and resistance is in ohms. So there's our final answer.